Greetings, my name is Shawn Chumbar, and I will be presenting on enhancing collaborative efficiency through multi-agent systems. This is a comprehensive literature review presented by myself. Introduction to AI and multi-agent systems. So currently the evolution of AI has expanded into multi-agent systems, which is a system that has many LLM agents. These LLM agents can handle very different types of tasks. The tasks that they're mostly known for are tasks such as that are in the domain of software engineering and artificial general intelligence. And the objective of this literature review is to basically do a deep dive into enhancing collaborative efficiency in multi-agent systems. So to start off, there's many different problems within this realm. There's looping problems where a multi-agent system might continuously go into feedback loops. There are scalability issues where if you're running one LLM agent, well, that's going to take some resources on your machine. However, if you're running 400 or 500, all of a sudden you have to scale to meet that demand. This brings me into my next point, resource management. All of these LLM agents have to run on some sort of machine. And when these are running on a machine, they're taking up system resources. And this kind of ties into the next one as well, where if there's a bad actor that has access to these LLM agents, then there's a security risks involved, such as leaking of private information and things such as that. You can think of ChatGPT and people who try to hack ChatGPT to gain passwords or API tokens. So to start, some of the solutions that are explored is to get supervising agents to monitor and guide interactions, feedback mechanisms for dynamic performance improvement. There's integration of plugins and specialized tools to make sure that these LLM agents stay on track, and as well as resource management modules to essentially act as a task scheduler in order to see which resources are being used. To go further into this, in the first piece of literature, the author proposes a hierarchical reinforcement learning model for fairness and efficiency in multi-agent systems. They use something called a FEN model, which balances fairness and efficiency with tasks. This is a hierarchical approach, which has a controller LLM as well as sub-policies that dictate which LLMs go in what order. And this can be applied in scenarios such as job scheduling and manufacturing. The next piece of article proposed AI agents for network service prediction and resource scheduling in software-defined networks. This is essentially AI for optimized network resources. This AI pretty much handles choosing which packets get sent where to what router, etc. This was mostly focused on 5G networks, as well as it had a heavy emphasis on resource allocation strategies. In the Meta GPT paper, they discuss a multi-agent collaborative framework. They use what's called a meta programming framework. This has a focus on collaborative problem solving and using multiple agents to solve a certain problem. And this led to efficiency in multi-agent tasks. Essentially, you'd have, let's say, one LLM acting as a developer, one LLM acting as a QA, one LLM acting as a PM, and all of these LLMs would work together to give feedback to each other and make their work product better. Lastly, in Data Interpreter, an LLM agent for data science. In this piece of article, they use data interpretation using LLMs. There's multi-agent coordination in data tasks, and as well as it enhances data processing efficiency. In CALM, this is a collaborative multi-agent, multi-reasoning path prompting. This focuses on a multi-reasoning path framework. This allows complex problem solving, and it improves agent collaboration by asking the agents to collaborate with each other and communicate with each other. So the strengths of these explored solutions is that it enhanced fairness and efficiency in multi-agent systems. It allowed for effective resource prediction and scheduling. It allowed efficient multi-agent collaboration through meta-programming, improved data processing, as well as allowed for better problem solving through multi-reasoning path prompting. So the weaknesses include implementation complexity, scalability concerns, resource allocation challenges, as mentioned earlier, and there's definitely limitations on the specific domains. In conclusion, multi-agent systems can significantly enhance collaborative efficiency. It addresses key challenges that are crucial for effective mass deployment. There is further research needed on feedback mechanisms, as well as further research on the security measures. And there has to be development of robust resource management modules. Here are the references that I used. Thank you very much.